In exercise 1 to 6, we need to solve the equation ax is equal b by using the LU factorization given for a. And exercise 1 and 2 solve ax is equal b by ordinary row reduction. So let us find it by the LU factorization. But first we know that Ly is equal to b. So that means we need to use row operation for the matrix L and try to solve it to find what is from here. We'll get our y. Also, we know that ux is equal to y, so we need to do row operation for uy, and then we will find what is from here our x. So the first matrix will be L, the second matrix will be U. So for this is the first step, this is the second step. So for the first step, we need to solve this one, L, and we need to row operate it for B. So our B is here given. So L is 1 minus 1, 2, 0, 1 minus 5, 0, 0, 1. And our b here minus 7, 5, 2. Let us do row operation and find what is y. So after doing row operation for the matrix L and we have the vector b, we get finally this result. So from here y is equal minus 7, minus 2 and 6. Now the second step is to use row operation for ux is equal y. So from here our matrix U is 3, 0, 0, minus 7, minus 2, 0, then minus 2, minus 1, minus 1. We solve this one for x, so we use our y minus 7, minus 2, 6, and we'll do row operation to find what is x. So here our matrix U and here our y, we do row operation until we get this form. So from here we conclude that x is equal 3, 4 minus 6. If we do row operation and x is equal b, we get the same answer, 3, 4 minus 6. I solved this one using the LU factorization, so you have to do it also as ax is equal to b. Do row operation to see that you have the same answer. So in 3 also we'll do the same thing. Here our matrix A, this is B, this is our L, this is our U. So for the first step we need to take Ly is equal to B. So our matrix L is 1, minus 3, 4, 0, 1, minus 1, 0, 0, 1. And our B is 1, 0, 4. We need to do row operation for this one to get what is our vector y. So after doing row operation for the matrix L and we have the vector B, we get from here our y is equal 1, 3, 3. So now let us solve for x. So then the second step here we need to solve ux is equal y. So our matrix is U, which is 2, 0, 0, minus 1, minus 3, 0, 2, 4, 1, and we use this vector 1, 3, 3 to find what is x. So after doing row operation for the matrix U and Y, we get from here our last form of the matrix, which is in reduced echelon form. So from here we can conclude x is equal minus 1, 3, 3. Again here with the number 5, we need to use the LU factorization to find what is the solution of ax is equal b. So this is our L, this is our U. First we use Ly is equal b, so we row reduce the matrix L to the reduced echelon form with b, and then we find what is our vector y. So from here we get y. In the second step we use ux is equal y, so we reduce the matrix U with the vector y to get what is our x. So after taking the U with the vector y, finally we reach to this form. So from here we conclude that our x is equal -2, -1, 2, -3. You can check the answer by finding ax is equal to b, so use row operation to reduce the matrix A to reduce echelon form, and you find what is x. In exercise 7 to 16, we need to find an LU factorization of the matrices. Note that L is the unit lower triangular. From this set, we need to do number 9 and number 11. So let us start by number 9. First, to find the LU factorization، على أساس نجيب ال LU factorization، ال U نجيبها عن طريق نسوي reduced للماتريكس الأصلية بدون ما نسوي سواب اللي هو بدون لا نسوي سواب للروز. نجيبها نخليها ان reduce نخليها فقط ان echelon form. الانتري اللي موجودات الليدنج انتري ما لازم يكون ان 1 1 1، فقط نخلي الماتريكس ان echelon form. الماتريكس ال راح نبنيها على حسب الخطوات اللي سويناها في الماتريكس الأصلية اللي هي 9 بعد الرو اوبريشن. ايش سوينا في الروز؟ راح نحدد على أساسها ايش بتكون اللي هي الماتريكس ال. طبعا نعرف انه الماتريكس ال بما انها اللور يونت تراينجولر، اذا ال راح تكون بهذا الشكل، اللي هنا راح يكون عندي 1 اللي بعدها بنعرفها ايش، هنا بيكون 0 0، بعدين نفس الحالة هنا عندي 1 وهنا 0 وهنا 1. So this is lower triangle. إذا نحن محتاجين نجيب 3 elements here، فقط 3 الانتري اللي موجودات هنا. So to find the upper triangular matrix we need -3 to be 0 first, also 9 to be 0. So that's from here. Row 2 will be equal row 1 plus row 2. Then row 3 will be equal -3 row 1 plus row 3. So this will give us the new matrix 3 -1 2, then 0 -3 12, then 0 -2 0. Now if we compare what we did here for this one, for -3 we said row 2 is equal row 1 plus row 2. For row 3 we said -3 row 1 plus row 3. So now we will take the coefficient of what we did here. So for this one, the first one here, it will be the coefficient of row 1 here 1, so we'll take -1. Now here the coefficient of row 1 is -3, we will take 3. So -3 here to be 0 we add row 1 plus row 2. So the coefficient of row 1 is just 1, so we will put here -1, the opposite sign. Here the coefficient of, here we have 9. To put it 0 we make it -3 row 1 plus row 3. So for -3 row 1 we will take 3 here. على أي أساس هنا أخذنا -1 وهنا أخذنا 3؟ لاحظنا أنه -3 كيف صارت هنا 0 ويأد اللي هي row 1 plus row 2، فآخذ العكس الإشارة. إذا سويت هنا إشارة الرو 1 موجبة إذا أنا أخذها سالبة، إذا أخذتها سالبة موجبة. طيب البوزيشن على حسب، أنا اللي سويته هنا في الرو 2 إذا هذا الكوفيشنت مال الرو 2، إذا سويت أنا هنا في الرو 3 إذا هذا اللي هو تبع الرو 3 اللي هي 3. نفس الحالة إذا أنا عندي الحين في الفيرست كولوم 3 0 0، إذا أريد هذه to be 0 أطلع منها نفس الشيء الكوفيشنت مال اللي هي الماتريكس هنا السكند كولوم. So from here -2 to be 0, that's mean row 3 is equal -2 over 3 row 1 plus row 3. This will give us the new matrix 3 -1 2 0 -3 12 0 0 -8. إذا من هنا نحن نقصنا الإليمنت هذا، الإليمنت هذا اللي هو اللي خلى اللي هي تصير هنا عندي 0، فأشوف هنا عبارة عن minus 2 over 3 رو 1. قلنا آخذ نفس الكوفيشنت لكن بالإشارة مخالفة. إذا هنا minus 2 over 3 إذا هنا it should be 2 over 3. إذا this is our matrix U, this is our matrix L. إذا from here A is equal LU, which means it is equal to 1 minus 1 3 0 1 2 over 3 و 0 0 1 اللي هي ال L. بعدين عندي اليو 3 0 0 minus 1 minus 3 0. إذا 2 12 minus 8. بنلاحظ هنا إن نحن لما نجيب الأبر triangular matrix اللي هي اليو ما نخلي الليدنج 1، يعني عادي نخليه بنفس القيمة اللي هي فيها، ما يحتاج يعني نقسم الثلاثة divided by 1 بعدين نكمل باقي، على طول نخليها نفس ما هي، ما يحتاج إنه الليدنج انتر يكون 1. So this is the LU factorization for our matrix A. So again here for 11 we need to find the LU factorization. So for L we know this one. Let us write it in different color. Sorry. So for L we know it is in this form 1, then we have here 2 elements, then 0 1 we have 1 element 0 0 1. So this is our L. We just need to find these 3 entries. For U we need to reduce this one, so we need just to make it in echelon form. So first we need to make this S to be 0, minus 1 to be 0. So from here row 2 is equal minus 2 row 1 plus row 2, and row 3 is equal 1 over 3 row 1 plus row 3. So from here we will take, for this element is here minus 2, so this one should be 2. For this one is 1 over 3, so this one should be minus 1 over 3. So after doing row operation we get the new matrix 3 minus 6 3 and 0 5 minus 4 0 5 1. So now we just left to, we want to make this 5 to be 0. So from here row 3 is equal minus row 2 plus row 3. This will give us the new matrix 3 0 0 minus 6 15 0 3 minus 4 10. So for this element we see from here we add minus row 2 plus row 3, so we'll take the plus 1, so this one should be 1. So from here we conclude A is equal LU, that means it is equal 1 2 minus 1 over 3 0 1 1 then 0 0 1, and the second matrix, which is 3 minus 6 3 0 15 minus 4 and then 0 0 10. So this is the LU factorization of our matrix A. So here be sure what we put here in the matrix L، يعني ما نيجي نسوي، لاحظنا مثلا هنا رو 3 is equal minus رو 1 plus رو 3، هل أخذ الكوفيشنت مال رو 3 ولا أخذ الكوفيشنت مال رو 2؟ لا، إذا كانت هنا رو 3 وهذه رو 3 إذا ما أخذ مال رو 3، أخذ مال رو 2. إذا هنا عندي رو 3 وهنا عندي رو 3 إذا ما باخذ مالها، باخذ مال اللي هو الرو الثاني. نفس الحال هنا عندي رو 2 وهنا ما عندي مال رو 2، إذا ما باخذ مال رو 2 باخذ مال اللي هي الرو 1. الإشارة أخذ نفس الكوفيشنت لكن أقلب الإشارة، إذا كان موجب أخذ سالب وإذا سالب أخذ موجب.